Dear students, myself Dr. Mallikarjun S. Biradar, Assistant Professor in Mathematics, Government First Grade College, Baswa Kalyan. This is session number 52 of the Graph Theory 2. And the topic of the today's session is condensation of digraphs. What is that condensation of digraphs? We will see in detail. Now, before defining what is before going for the condensation of digraphs, we will discuss some ideas. What do you mean by component and fragments of a digraph? That is very important. First, we try to understand what is the component and fragments of a digraph. Then we will think of the condensation of a digraph. Each maximal connected, it may be weakly connected or it may be strongly connected subgraph of a digraph D will still be called a component of D. What do you mean by component of a digraph? Each maximal connected, it may be weakly connected or it may be strongly connected subgraph of a digraph D will still be called a component of the digraph D. But within each component of D, the maximal strongly connected subgraphs will be called the fragments, or you can say strongly connected fragments of the directed graph D. Okay, so just don't get confused. First, we are considering maximal connected subgraph. Within each component of D, the maximal strongly connected subgraphs will be the fragments. Okay, so these are the two ideas. One is a component and another one is a fragments of a digraph. Now, corresponding to connected components of a digraph, there are three different kinds of components of a digraph. Okay, don't get confused. Corresponding to connected components of a graph, there are three different kinds of components of a digraph. What are those? We will see. As we have got strongly connected, unilaterally connected and weakly connected. Okay, here also strong component, unilateral component and weak component. So we will see these three components, different components. So what would be the strong component? A strong component of a digraph is a maximal strong subgraph. See the difference. A strong component of a digraph is a maximal strong subgraph. And what is the unilateral component? A unilateral component is a maximal unilateral subgraph. And a weak component is a maximal weak subgraph. So graph, subgraph, graph, maximal subgraph, what we have studied in case of undirected graph. Here slight difference. Okay, so these are the three different kinds of components. One is a strong component, another one is unilateral component and weak component. In all these cases, depending on the word strong, unilateral, weak, there must be a maximal component of that kind. Okay, if it is strong, there should be a strong subgraph, maximal strong subgraph. If it is unilateral component, there should be a maximal unilateral subgraph. If it is weak component, when it will be a weak component? If there is a maximal weak subgraph. So then these are the three different kinds of components we have observed. Okay, so it is very easy to verify that each vertex and every arc, each vertex and every edge of a digraph D is in just one weak component. If every vertex and every arc of digraph is in just one weak component and in at least one unilateral component. Okay, so you will get one weak component, you will get one at least one unilateral component. Furthermore, vertex is in exactly one strong component. One vertex, like a trivial graph or a trivial digraph with only one vertex is also considered as a strong digraph. So you can say furthermore vertex is in exactly one strong component. and an arc lies in one strong component or none. Okay, so depending on whether or not it is in some cycle, that depends on a cycle. If it is on some cycle, then it will be a strong component. Otherwise, no, because there should be two ways, A to B and B to A. Okay, so depending on the situation. Okay. Now, the strong component of a digraph are the most important among these. Out of these three, weak, unilateral and strong, the strong component of a digraph are the most important among these. So one reason is the way in which they yield a new digraph. Sorry, so what I'm going to say, one reason is the way in which they yield a new digraph, which although similar retains some structural properties of the original. Okay, so let us consider the subsets, say S1, S2, S3 and so on and so forth, Sn of the strong components of D. So we are going to consider a strong components of the digraph D with the subsets S1, S2 and S3 and so on and so forth. Okay, so these are the basic ideas. So in the components there are three types. Okay, so now we will see what is the condensation of a digraph. Okay, so like we have got different concepts in graphs. So like that, condensation of digraphs. The condensation of a digraph D is denoted by D star. So D star is the condensation of a digraph D. Has the strong components of D as its vertices. So first you have to identify which are the strong components of the digraph. So each strong component corresponds to a vertex in the condensation of a digraph. So as its vertices, and we with an arc from Si to Sj. So Si is one vertex, Sj is one vertex corresponding to the strong components of the digraph D. When we join these two Si to Sj, whenever there is at least one arc in D from a vertex of Si to a vertex in Sj. So what I am going to say is that the vertices of the condensation of a digraph E are the strong subcomponents. You can say the components, strong subcomponents of D are considered as vertices of a new graph in which the two vertices are adjacent, Si and Sj. Whenever there is at least one arc in D from a vertex of Si to a vertex in Sj, then such a graph is called condensation of a digraph. So another way of defining the condensation of a digraph, okay, how to define in another form, that we will see. The condensation D star of a digraph D is a digraph of course, in which each strongly connected fragment is replaced by a vertex. Already we have discussed what we mean by component and the fragment. Okay, the fragment already we have discussed. The condensation G star of a digraph D is a digraph in which each strongly connected fragment is replaced by a vertex, and all directed edges from one strongly connected component to another are replaced by a single directed edge. Let me consider one example to clarify this concept. Okay, this is an example. So in this graph, a digraph and its condensation are given. So let us consider the graph D. Okay, so now we have labeled the edges. You can say S1, S2, S3, or you can say the components, not the edges, the components. So this is one component, this is another component, this is another component. Okay, so first you have to identify the maximal strong components of the digraph. Okay, so how many strong components are there in this digraph? S1 is one such a strong component, S2 is another such a strong component, and S3 is another such a strong component. So the strong components of the digraph D represent the vertices of the condensation of the digraph D, which is denoted by D star. Okay, so these are the three vertices corresponding to those strong components, and two vertices are joined. Two vertices are joined if there is a common vertex between those two sets, then those two will be adjacent. Okay, so this is one example to clarify the concept of the condensation of a digraph. Okay, so now what are the observations on this definition of a digraph, sorry, condensation of a digraph? Let us think. There are some observations based on the concept. From the maximality of strong components, the condensation is D star of any digraph D has no cycles. You can see the previous example. So this is the condensation of this graph. There is no cycle at all. There is no cycle at all. This is one important observation. Okay, then the condensation is D star of any strong digraph D is the trivial digraph. If you consider a strong digraph, which it is a trivial digraph, of course, then the condensation of that will be a trivial digraph. The condensation D star of any strong digraph is the trivial digraph. You will get only one vertex because the entire component will be the stronger component. Okay, so in that case you will get a trivial digraph as a vertex in the condensation of digraph. Next, what would be the third observation? A digraph is unilateral. Unilateral means one way. A digraph is unilateral if and only if its condensation has a unique spanning path. Definitely, there must be a unique spanning path. What do you mean by spanning path? A path containing all vertices of the digraph. Okay, there must be all vertices, and there must be a path from U to V. So then that will be a unilateral digraph. So a digraph is unilateral if and only if its condensation has a unique spanning path. So these are the observations. Okay, so far what we have discussed in this session, so we have discussed three different components in the digraph. One is a strong component, another one is a unilateral component, and a weakly component. Okay, then we have considered the concept of condensation of a digraph, in which the vertices of the condensation of digraph are the strong components of the digraph. Okay, and we have observed one thing, one important observation is the condensation of a digraph has no cycle at all. Okay, so but it has a spanning subgraph. There is a spanning subgraph in the condensation containing all vertices. So these are the ideas what we have discussed in this session. So these are the reference books. With this we conclude this session. Thank you.